This problem is asking us to find a systematic sample. Pause the video to read the full problem statement. I want to go back to our homework, specifically this objective 2, this is in section 1.4, on how to obtain a systematic sample. Let me minimize this so you can see a little bit more here. There are actually some steps that are very systematic in finding a systematic sample. So notice here that the first thing we need to do is identify the population size. We're going to call that capital N. We'll then determine the sample size. We'll call that this lowercase n. And then we'll compute K by dividing those two, population divided by sample size. If need be, we'll round down to the nearest integer. And I can see that in this example that's been done correctly here. And that's serving as our value K. All right, so I'm just showing again back here in these steps. Step 4 asks us to randomly select a number between 1 and K and call that number P. But in practice, as far as my math lab goes, we need to be given the value P. So that's what we're given here. Suppose that we randomly select 14. So 14 is going to serve as P. Then we're going to actually calculate the sample. The sample will consist of the following individuals: P, P plus K, P plus 2K, and then the last one that we pick is going to be P plus the quantity, lowercase n minus 1, remember that was the sample size, times K. So based off of what we're told in that last step, we're going to start with the person numbered number 14. The next person that we select will be 90 beyond that. So we're going to do 14 plus 90, and we'll get 104. Now I have brought up this calculator here just to show and verify that when we add those together, yes, we get 104. If I go back, I know I'm switching a lot of screens here, but if I go back, the next person that we select will be twice as far away, 2 times 90 in this case. So I'm going to show that a couple of ways. I could take it like this, that I'm adding 90, that remember that was the second person we select, and then 90 again. Or, as the formula says, I can add 2 times 90. And notice that those give us the same value, 194. The last one that I'll select, sorry, wrong screen. The last one I'm going to select is the person with this number, P plus the quantity n minus 1 times K. So I need to now grab that additional value, lowercase n, or this sample size here of 60. So I'm going to write P plus, and then in parentheses, that sample size 60 minus 1 times, outside of the parentheses, 90. Remember, 90 was what we calculated K to be. Now, you might look at that and think, well, why am I subtracting the 1? So let's just explore for a second. What if I didn't subtract the 1? What if I did just the sample size 60 times 90, which remember 90 is representing K here. What I'd end up with is the person whose number is 5,414, but I only have 5,405 employees. So I'm actually going too far. So you want to back up 1, or in other words, think of it like you're subtracting 1 jump of 90 here. And remember that gave us 5,324 when we followed that formula from the text.